So you understand this. Once again, object is the implicit parent of all classes. Okay, any class parent is object. Okay, now the toString method, I believe I did this with the book and dictionary because I reminded myself we did that already. And the other method is the equals method, right? So let's look at the equals method. Okay, the equals method of the object class returns true if two references are aliases. So this is another concept. What does aliases mean? What does that mean? Anyone? But what does that mean? I think I have the answer here. They are the same. They are the same what? I need you to tell me the same what, meaning the two references are pointing to the same memory address. That means you have this one memory address location, you have object 1, and you have object 2, and maybe another one, okay? They all point to the same address, the same object. That is, they are aliases of one another. They are the same thing, but different names. That's what aliases is. So if you do not override the equals method, the objects equals method will always test to see if they are the same address, if they reside in the same address, if they are the same, pointing to the same object. So, you know, that's not useful for your program. Think about it. When you talk about two students, right? If one student and if the two students have exactly the same name, same age, same banner ID, then they are the same. They are not, but they can be two different objects. One is fake, the other is real. You can say that. So that's when the equals method doesn't work if it tests only the memory address. So we have to override the equals method in any class to define equality in a more appropriate way. Okay, so so let's see. As we've seen, the string class defines the equals method to return true if two string objects contain. Let me clear my throat. Somehow I just feel need to pause. Okay, so when you test two strings, if you remember, if you use the double equal sign, you are testing the addresses, right? We discussed this in chapter 3. If you want to test the content of the two strings, you use the equals method because the string class redefined the equals method, so it tests the content. This is why we should always override the equals method in our own class to decide what makes two objects equal. Okay, so let's look at our, where is it? My Eclipse. Okay, so let's look at the words, right? Book. Okay, and remember last time we redefined the toString method. This is what we did last time, right? We redefined it. And dictionary, we redefined it also by calling the super.toString method and add that to the number of definitions. We discussed this last time. If you don't remember, go back and watch that video. Okay, so we redefined the toString method. Now let's redefine the equals method. Before we do that, let's just test, okay? So let's test and see. I'm going to do this print line, right? Let's test and see. We have two objects. They are both dictionary, Webster and Dick. and dict. Let's see if they are the same, right? Webster dot equals dict. Yes. Okay. This will give you a false, right? Because this will give you a false because they are two different objects, right? Okay. Where is it? Here. So you can see it's false, right? Because it's two different objects. We have two different objects here. Now, if I, it will always be false, no matter what, because we did not redefine equals method. So if they are two different objects, then they are the same. But if we say, let's do another one, dictionary, D equals to Webster. Okay, now these two are aliases to one another, right? Because they are pointing to the same address. So now this should give you true. Only in this case, it gives you true. Okay, let's run. And it gives you true. So when it points to the same address, it's true. So that's the equals method. Now what I will do is I will just comment this out. Okay, I'm going to work with these two and I'm going to remember a dictionary. What does a dictionary have? A dictionary have number of definitions. It also has number of pages. So if the two dictionaries have the same number of pages and the same number of definitions, then they should be equal, right? So now the two dictionaries should be equal because that's how we defined the dictionary. We only defined it to have number of pages and number of entries. So now it should be equal, but it's not. It still is false because they are two different objects. Do you understand me, everybody?
Yes.
Yes, okay. So now this obviously, this tells you that equals method here is useless because I have two dictionaries exactly the same, but it still tells me they are not the same. So that's when you need to redefine your equals method. Okay, so let's redefine the equals method. I'm going to put it here. Okay, if you look at the, where is it? Here, right? Equals. No, not here. We have it somewhere. It doesn't matter. Equals returns a Boolean, right? So whether they true or false, and that's equals. And equals, we still have to go back. I want to show you. If you look at it, where is that object class? Maybe overriding. It shows you the. Do you remember that class that shows you the object methods? Where are they? I cannot find it. So maybe it's in chapter 10, but it's all the same. I'm just going to do it here. We will do it in chapter 10. If we do it here, we don't have to do it in chapter 10. So it accepts an object, okay, equals. It accepts an object from the parent class. So we redefine it. And how do we define if the two objects are the same? When their instance variables values are the same, then they are equal, right? So this is the object you want to compare with. And so if you look at this, that would be this parameter. Okay, this dict would be the object that you are comparing with. So we will do this. So how do we define equal, right? If the current pages, okay, number of pages, so the current pages, it's an int, so we use double equal sign to compare them. It's equal to the object that is passed, right? O, and get pages, then we return true. Okay, so if the two number of pages are the same, then you return true. And then you will see it will not compile. The reason is O is what type? What is the type of O, everybody? What object is O here?
It's an object.
It's an object. Does object have the get pages method?
No, it does not.
No, it does not. So what we meant is this object O has to be a book. So, but the equals method in the object class accepts an object. Just know that, right? Remember, when you override, you cannot change anything. So the equals method in the object class accepts an object. So we have to use this parameter list. But here we can cast it back to a book because it has to be a book. Okay, and when you cast it, you have to put the correct parentheses here so that it will do the casting first, right? And then it will do this. Okay, so else return false. Okay, so if you look at the definition, it's very, very easy because you are comparing these pages. What is this? This is from the current class, right? And you're comparing the given object number of pages by calling the method, because a book object has this method. And because you are passing an object, you need to cast it back into a book to call this method. So notice the parentheses. You have to make sure this is done first. The casting is done first. And then you call get pages. Okay, so that's the book class, right? Now let's go to the dictionary class. For dictionary, you do not even need to define it. Why? Everybody, why don't we need to override the books equals method? Do you think? Why? Look at the class. Should we? I'm going to ask you. So we need to redefine it. We need to redefine it because even though here it's all the same at the beginning, right? When you create the dictionary object, but you can change it. So the number of definitions might be different at the end, in the end. So let's redefine the equals method then. Public Boolean. You know, before we redefine it, I'm going to call it so that you can see. Okay. So let's go to words. And now let's see. Remember, just now, this tells you they are not the same. And now let's see if they are the same. Okay, remember, just now it's false, right? So now we run and you can see it's true. That's because we redefined the equals method. Okay, when we redefine the equals method, we meaningfully compare the number of pages because the instance variable for a book is the number of pages. We don't have a title, we don't have anything. So the only thing to compare is the number of pages, and that's what we did. Do you understand this, everybody?
I have a question about the equals that you used.
Okay. This one?
Yes. How come?
Okay.
How come it's not comparing addresses with equals?
Because pages, that's a great question. It's an int. It's a primitive data type.
But any other time it would, if it wasn't?
Any objects. When you compare two objects, it will compare the addresses. But for primitive data types, it's just regular. It compares the value.
Okay, thank you.
That's a great question though. Yes, sometimes students can get confused, right? When it's primitive data types, int, float, double, char, boolean, and what else? Short, byte. All those you can compare with the double equal sign. You actually cannot use the equals method because they are not classes, right? So yeah, Okay, any other questions? So that is that. Now, if we go back to words, and this is a dictionary, so we can actually set the number of definitions. Set number of definitions, right? Let's set it to, remember for dictionary by default, its definition, number of definitions is this, but we will set it to 400. So now it's different from Webster, because when you create Webster, right, its number of definitions is this many. But now I'm changing, and when you create DICT, its number of definitions are the same. It's the same. Now I'm changing it. I change it to 400, but this will still say true, while they are actually different, right? This still tells you true. Why, everybody?
So it's using the equals method from the parent, and it only compares number of pages, not definitions.
Yes, yes, that's why. You see, that's the danger, right? When it calls equals method, the Java system goes to dictionary because these two are dictionary objects. It goes to dictionary to look for the equals method, and dictionary doesn't have it. So it goes to its parent and finds it, and it uses this. And this equals method compares what? The number of pages only. Okay, so here these two have the same number of pages. So they're the same. That's why in your dictionary class, you need to redefine it. Otherwise, it's not accurate, right? So let's redefine it. Equals, and once again, we call it object, right? Okay. Oh, you can call it anything, of course, but the parameter has to be object. Okay, so how can a dictionary, two dictionary be equal? It has to have the same number of pages. It has to have the same number of definitions. So for the number of pages, we have already defined this equals method. We can call it, we can reuse it. Okay, so here we will reuse it. We will say if, okay, if, and remember to call the method in the parent class, you will simply say super, right? And here we are comparing it as a book. Equals, oh, I think I have to, I'm not sure if I need to cast it into a book. Let's do that first, okay? If the super equals to the super, that's the parent class, you call the equals method, and this is the object, right? I'm not quite sure if I need to cast it. If we need, we will do that. If this is the case, then we need to test what? If they have the same number of pages, we need to test, I'm doing it step by step. We need to test the number of definitions. Because it's an int, we use the double equal sign equals to, here, it actually has to be a dictionary, right? I think I need to put 2 here. Dot, no, not dot. I'm casting it, right? Okay, dot, get definitions. Get the number of definitions. Okay, so here I'm testing to see if the number of pages are the same. If they are the same, then test to see if the number of definitions are the same. If they are the same, then they are the same. Else, yeah, if the number of definitions are different, else return false, right? Or you don't even have to have an else. You just say return false. You don't even have to have the else there. So that means, oh, I only have this. You know what? You don't even need the else. If that doesn't execute, then you return false. Okay. So if this condition is not true, you will return false, right? This is the second statement. And if this condition is true, but this condition is not true, you don't execute this statement, you return false. So that's why just now you need another else because you have two if, and we don't want to do that. Do you understand this method implementation, everybody? Tell me if you understand the implementation. Do you resume recording? So now you can see that it returns false, right? Because they have different number of definitions. Now let's give it the same definition. Let's do Webster dot set definitions. Okay, 400. And now they should be the same. True. Right? That's the equals method. And to override the equals method, if you look at it, it is a little bit complicated. But just know what are you comparing? You are simply comparing the instance variables, because instance variables are the ones that describe an object. Okay, models an object, right? That's the model. So you simply compare all attributes to implement the equals method. Any questions about this, everybody?
Is there any reason why we didn't just, instead of using an object, yeah, we could use just book so we don't have to cast it?
The reason is this equals method is from, we are overriding it from what? From the object class, right? The object class has three methods: clone, equals, and toString.
Right.
And so you have to use the same parameter list.
Could you change it?
Yeah, go ahead.
Could you change it to a book object, and then would that be, I guess that would be overloading?
But overloading, you don't have another method here, right? But then when you do that, you are not using the objects classes method. That's the only thing. When you compare it with, for example, it's a little bit complicated. If we say book, oh, okay, let's say dictionary. Okay, dictionary is a book, and you say I'm not going to accept. Here you actually have to. You see, the good thing about this is when it's an object, it can be anything. But if you simply make it into dictionary, then how do you compare book? You cannot compare book. Does that make sense, Jesus?
Yes, that makes sense.
Okay, if you make this dictionary, you cannot compare book because book is the superclass. You cannot do this comparison, the number of pages. So if you have a more generic object, you can cast it down, right? You can cast it to a more specific object. But when you have a more specific object, you cannot cast it back to a more generic. It would be impossible. So using, can you use book here with the superclass? Yes. But then when you have other objects in the same array, when we talk about collections in chapter, in the third class, you will find that will create problems. Okay. So you just use object and cast it. And this is the syntax to cast, right? And you cast it back into a book so that you can call the get pages method, because object does not have the get pages method. I think I'm a little bit ahead of myself here because this is more or less from chapter 10, actually. I don't know why I did this, but the two chapters are really interconnected anyway. So that is the toString and equals method. We did the examples for both. Now, any other questions? Okay, let's talk about abstract class. Okay, abstract class. It's a placeholder. You know, what is a placeholder? This is a placeholder, right? These are placeholders that is going to accept the value. So abstract class is a placeholder. It's a place where it's like a repertoire. Okay, in the class hierarchy that represents a generic concept. So some concepts are so generic that you cannot really create an object from it. Actually, if you think about it, vehicle. What is a vehicle? Can you create a vehicle? Not really. Why? Because any vehicle must be either a car or a truck or an SUV or maybe airplane or bicycle or anything. Any vehicle must be one of those. There is not a generic vehicle that you can create, you can use, right? In that case, you can make vehicle an abstract class. It's a generic concept. Okay, an abstract class cannot be instantiated. You cannot create an object from it. We use the modifier abstract, just like this. So once you put this here, okay, public abstract class product, this product becomes abstract, then you cannot do product P equals to new product. You cannot do that because it's abstract. I can't even write here. Okay, because it's abstract. So this would be wrong. Okay. An abstract class often contains abstract definitions, like an interface. Okay. Unlike an interface, an abstract class, an abstract modifier must be applied to each abstract method, because an abstract class, unlike an interface, typically contains non-abstract methods with full definitions. So interface, remember, an interface is a collection of abstract methods, right? An abstract class can contain abstract methods or non-abstract methods. That's why if it's an abstract method, you must put the abstract keyword ahead in front of it. Otherwise, it would not be an abstract method. So that's the difference, okay? A class declared as abstract does not have to contain abstract methods. Simply declaring it as abstract makes it so. So this is simply saying a class can have abstract methods, but it doesn't have to. Even a class with no abstract methods can be an abstract class. So for example, here, right? If you do this, this is fine. You see, it's fine. There is no abstract methods here, but it's still okay. That's what this means. That means a class declared as abstract does not have to contain abstract methods. But if your class has even one abstract method, it must be declared as abstract. What does declare mean? That's what that means. You must place the abstract keyword in front of the class. Okay, any questions? And once again, an abstract class is used when a concept is so generic that it's not meaningful. You cannot even create an abstract, a concrete object from it. So it's too generic, too abstract. It's just a concept. Okay. I will let you read this instead of me reading. I will let you read it. If you are a child class of an abstract class, what must you do?
Override the abstract method of the parent?
Yes. You must override all the abstract methods in your parent class. What if you don't? If you do not, what do you have to do?
If you don't, it'll just be considered abstract also.
Yes, yes, yes. If you do not override all the abstract methods, then you will declare yourself to be an abstract class also. So, so in that case, let me ask you this question. Where should the abstract class be in the class hierarchy? Should it be the parent or should it be the child?
The parent?
Parent, okay? It should always be the higher level because it's so generic, right? The child class has to override everything that's abstract. And therefore, an abstract method cannot be defined as a final because it is meant to be overridden. Otherwise, it's meaningless. It cannot be defined as static because you cannot create an object from it. No, that's not the reason. It cannot be static because a static method can be called through the class name. And if the class is abstract, then that method might not have been implemented. So you cannot make it static, right? Okay, that's that. Any questions, everybody? Okay, I already talked about this. I will let you read this and see if you understand it. Okay, do you understand it, everybody?
Yes.
Okay, I don't need to say more, right? Okay, if you understand it, then let's move on to the next one. Interface hierarchies. Interface can also, inheritance can also be applied to interfaces, okay? So what are some methods defined by the object class? These are the three objects. I already gave you the answer. And notice that for equals, it accepts an object. Okay, that's why Jesus asked that question. That's a great question. And that's why, because the method in object class accepts an object parameter. Okay, what is an abstract class? An abstract class is a placeholder. It's useless because it's useless in the sense of creating objects. You cannot create an object from it. But why do we need an abstract class? Because we can place all the common characteristics and common behaviors in that location, in that class, and then the child class will define them differently. Okay, so that's why it's useful. And you can read this. Just remember, an abstract class cannot be instantiated. That means you cannot create an object from it. Okay. Designing for inheritance. I will let you, okay, designing for inheritance. The main thing to remember is that you want to put the common behaviors and the common attributes higher up so that all the children classes can inherit them. Okay, so I will let you read this. I'm giving you examples here anyway. Sports team and players, what's the relationship?
I would say that sports team is like in a place of how you have on here, it's person and child. The player is part of the class, or like the parent class is the sports team, and then you derive the player from the sports team.
Okay, so you say sports team is the parent class and player class is the child class. Okay, any other, Brian, thank you. Any other students, any other opinions?
Would it be a composition, like a has-a relationship?
Why? Why?
Because a sports team has a player, but a player doesn't have a sports team.
Okay. Okay, that's Tyler. Okay, thank you, Tyler. Anyone else? So we have two relationships here. One is a relationship that is a player is the child class of sports team. And another student said sports team has players. Which one do you think?
Yeah, I'm going to go with has. Aggregation.
Okay. It's has a relationship, everybody. Just ask yourself this question. Okay, ask yourself this question. Is a player a sports team? No, you cannot say that, right? You cannot say, is a player a sports team? If the answer is no, then it's not an inheritance relationship. So does a sports team have players? Yes, that's true. It has a relationship, aggregation. That's correct. Okay, let's move on. I will let you read this once again. Okay. When you do the constructor for the child class, the first line of code should be calling the constructor of the super class, right? Using the super method. Okay. And override general methods such as toString, override them always in your class. Use abstract classes to represent general concepts. Okay. Visibility modifiers, what are they, everybody? What are the 3 visibility modifiers? They are represented like this. In UML, what is this?
That's public.
This one?
That's private.
This one?
And protected.
Yes. Public is visible to all. Private is visible only in the class. And protected is visible to the child class as well as all classes in the same package. Okay. If you put the final modifier ahead of the class name, in front of the class name, then that class cannot be overridden. Oh, method. Okay, a method. Or if you put the final modifier in front of the class name, that method, that class cannot be extended. It's final. So an abstract class cannot be declared final because you need to extend that abstract class, right? So don't use final when it's abstract, and a parent class should not be final. Okay, a method, if you need it to be overridden, you cannot make it final. So we are done with chapter 9, everybody. Any questions? Objects, that's polymorphism. It morphs into different objects. That means one reference variable can reference different objects at different times when the program executes. Okay, so so it's a very, very useful mechanism. What defines object-oriented design and programming are 2 characteristics. One is inheritance, which is what we just discussed. One is polymorphism. Those are the 2 most distinguishing characteristics of object-oriented programming: polymorphism and inheritance. And we are covering both right now. Okay, we covered inheritance already. Now in this chapter, we focus on polymorphism. That means one reference variable can reference different objects at different times. Okay, so late binding. Let's look at what this means. There are 2 kinds of bindings: static binding and dynamic binding. How about I will let you read, and then we discuss it. Do you understand this, everybody? I think you read it once and then I explain it, it may be better, right? Static binding means when you compile the program, make it into object code, the method body is already fixed. That means, oh, if your method name is called average, right? Then at compile time, I will already have the method body, how to do the average. Already it's bound with that code, with that name. Runtime binding or late binding means when you compile, the system will only check to see if that method exists. Okay, if it exists, think about it. With a superclass and subclass, we have many method bodies for one method. think about the toString method, right? We have that body, we have that name, but we override it. We have many different bodies of the toString method. We just illustrated that. An equals method, many different bodies, definitions. So at compile time, if the method body is bound to the name already and compiled into object code, that is called static binding. But if at compile time, the system only checks to see if that method name exists, it doesn't care which body. Okay, if the name is there, it will compile. And at runtime, it will depend on whether that object is a child class or superclass. It will decide which body to use. Let's look at this example. We actually have this here, right? So if you look at this, okay, this is the word method, the word class. When we do this, okay, when we compare, when it compiles, at compile time, the Java system only checks to see if equals exists. It will always compile, even if you don't implement them. Why? Because object has this method defined, if you remember, right? It checks to see if the two addresses are it checks to see if they are the same object. So this method is defined in the object class. That's why even if you don't have it, if I don't have it, let me comment this out, okay? Right? It will still compile. You know, I commented out. It still compiles. Let's go back. Okay, it still compiles. Why? Because once again, it checks only to see if that method exists, and that method exists in the object class, so this compiles. But when it runs, because this is a Webster, this is a dictionary object, when it will go to the dictionary class to find the method. If it's not there, it goes to book. If it's not there, it goes to the object class, right? So at compile time, it only checks to see if the equals method exists. And it does, right? It's in the object class. At runtime, it will see, what is that object? Oh, Webster is a dictionary object. Let's go to the dictionary class to find that method and use that definition, that body. And this is the method body. That's what that means. So at compile time, it checks with the object class. At runtime, it actually looks at this method name, this object, and see that it's a dictionary object. So it goes to the dictionary to look for that method definition. That's what this means. Does that make sense, everybody? Do you understand it? The term polymorphism literally means having many forms, and polymorphic reference is a variable that can refer to different types of objects at different points of time. The method, we will look at an example, okay? The method called through a polymorphic reference can change from one invocation to the next. This is due to the fact that Java uses dynamic binding, okay? All object references in Java are potentially polymorphic because they are all objects, right? Okay, they change it. So here is another example I will let you read. Let's have this example also. Okay, let me give you this example. Can I simply make this book? This is a book reference variable, but you are pointing to a dictionary object, and you can see it doesn't compile because this is a book reference. It doesn't compile because it's a book reference. So at compile time, it looks for the method in the reference variable. The reference variable is a book. and here it doesn't compile. So you have to actually, I'm once again, I'm a little bit ahead of myself. We will discuss this in a minute, actually. So I will take this back. This is not a very good example. Oh, not book, dictionary, and that's what I meant. Okay, now it will compile, right? So, so you can actually declare it as a book reference, and then you can call the method. Here, actually, you see this, oh, this compute. Okay, let's forget about this. I'm too ahead of myself. I have to make many changes there to make it compile. Okay, but this is what this means. Let's go to the next slide. When we look at the employee example, you will understand that much better. And here, after this, after we discuss this, you will understand it much better. Okay, an object reference can refer to an object of any class related to it by inheritance. That means it can, an object reference can point to anything that is a child, right? Okay. For example, if holiday is the superclass of Christmas, then the holiday, a holiday reference could be used to refer to a Christmas object. See, this is a holiday reference. That's the reference type. It's a reference variable. The reference type is holiday, but it can be pointed to, it can point to a Christmas object, just like what we did. This is fine, you see. A book reference variable can point to a dictionary, which is a child class object, right? Okay. So this is fine because Christmas is a holiday. Just remember, Christmas is a holiday. Okay, these type, I will let you read. I think when you read it on your own, it's better. Okay, so once again, if you look at this, this is, you are assigning this Christmas object to this holiday reference variable. You because this is the assignment, this is how it works. It goes this way, right? Assigning this to this. So you always ask yourself, is this this? If that's the case, then it's okay. If it's not the case, it's not okay. So you ask yourself, is Christmas a holiday? If it's yes, you can do this. If it's no, then you cannot do that. So that comes to this example. No, it's not there. So if you change this to Christmas, okay, if you say Christmas, day, and then you say day is equal to new holiday, this will not be okay. Because you ask yourself, is holiday a Christmas? No. A holiday can be a Halloween. It can be a Thanksgiving, right? So a holiday is not Christmas. So this is not okay. That's what this is. That's what this is saying. Do you all understand it, everybody? Always remember to ask the question, is this this? The answer decides whether you can do the assignment or not. Okay. So assigning Christmas object to holiday is okay, right? Because Christmas is holiday. That means assigning a child object to a parent reference can be okay. Simple assignment. Assigning a parent object to a child reference can be done also, but you have to cast it. And we will talk about that. After all, Christmas is a holiday, but not all holidays are Christmas, right? Superset, subset. So now let's look at this. Now, suppose the holiday class has a method called celebrate, and Christmas overrides it. Which method is invoked by the following? I will let you read, and then we discuss it. Do you understand it, everybody? I
think
think
so.
I have a video of this specifically for this in chapter 10. So please watch that video. But let me explain. I know someone said something. Let me explain it. This means, okay, for example, holiday is the superclass, right? Christmas is the subclass, the child class. Both of them have a method, celebrate. So holiday has a method named celebrate, and Christmas overrides that method, celebrate. So both of them have this method. If you call this, okay, if you have this call they dot celebrate, if they is a Christmas object, it will call the Christmas method. It will call the Christmas method. If they is a holiday object, it will call the method in the object. So that whatever type, whatever object this is saying the type of the object being referenced, not the reference type, determines which method is called. So here, this is what it means. What type of reference is this? The type of reference is holiday, but what object is being referenced? Christmas. Does that make sense? I know it's a very, it's not easy to grasp, but that's what that means. So this is the reference type, because when you declared it, that's the reference variable. But this reference variable is referencing, it's pointing to a Christmas object. Okay, so when you do this, if both holiday and Christmas has a celebrate method, it depends on what object it is. In this case, the object is a Christmas object. So it will call the method in the Christmas class. Does that make sense, everybody?
Yes.
It takes a while to let it sink in. Really, you need to have it register. It takes some time to register that, not immediately. I don't believe immediately it registers. It takes some time. Okay, so the reference type and the referenced objects are two different things. I'm going to repeat that one more time. This is the reference type. When you declare it, whatever type it is, that's the reference type. This is the object being referenced. That's the type that's being referenced. So dynamic binding, right? At runtime, which method body is being used depend on what type of object this is. If it's a holiday object, if it's new holiday, for example, okay, holiday. Then if it's a holiday object, it will bind with the method in the holiday class. But in this case, it's a Christmas object. So it will go to the Christmas class and bind with that method body. That's what this is saying. Questions, everybody?
Can you repeat the holiday is a what?
Say it again, Jesus.
The thing that you said at first is a reference.
Okay, so this is the reference type. Okay, that's the reference type. This is the type that's being referenced. This is a type. So day is a holiday type, but it's pointing to a Christmas object because Christmas is a holiday.
Okay, gotcha.
Okay. And so when we say the type of the object being referenced, in this case, that's the type of object, not the reference type. This is the reference type. So the type of object being referenced, not the reference type, determines which method is invoked. That's what that is. Okay.
Thank you.
Any other questions? My watch tells me you need to stand. I didn't stand, and it says you did it. I don't know why. Okay. Polymorphism via inheritance, right? This is what is this? Via inheritance. Okay. Note that the compiler restricts invocation based on the type of the reference. So if Christmas had a method that holiday didn't have, the following would cause a compiler error. So this is a little bit confusing. So remember, when it compiles, it looks for that method in whatever the reference type is. When it actually runs, it uses the body in the actual object being referenced. That's a very, very important. So this is saying, okay, let's assume two classes, holiday and Christmas. Those are the two classes. Christmas is a superclass. Holiday is a superclass. Christmas is a child class. Holiday doesn't have the getTree method. Christmas has a getTree method. This will not compile because holiday, a day is a holiday reference variable. At compile time, it looks for the method in the reference type. At runtime, it uses the body of the type being referenced. Do you understand that? That's almost like tongue twister. Okay, this time let's be more specific. Print line, celebrate, let's celebrate. Let's light up the Christmas tree. Okay, so this is a more concrete message, right? Okay, so here, test holiday. Let's do another class. Okay, let's do another class. This way we can illustrate it better. Okay, this class we call it Thanksgiving. Okay. And so for this one, we also okay, here, public void celebrate. Using the words, those classes don't work as well because I have to change a lot of things. This is better. Okay, system.out nano time. My keyboard is getting sticky, to be honest. Thanksgiving. Let's give thanks. I think we really should all be very thankful to whatever we have. That's my philosophy. And you know, if you keep a positive attitude, your life will be a little bit happier. Okay, so okay, now I can create a holiday reference variable. Why? Oh my God. Okay. So holiday, right? Day. Okay, that's what we had. So I have that is a reference variable, right? Now I will say day equals to new Christmas. Okay, now what is Christmas? What is wrong? Christmas. What did I do wrong?
Do we need to extend to the parent class?
Yes, definitely. Yes, very good. Thank you. I forgot that. Yes. Okay. We need to extend. Forgot that. We cannot forget that. Okay. You're absolutely right. Thank you. Christmas and Thanksgiving. Okay. Okay. So now this is okay, right? So what is the reference type of day, everybody? What is the reference type?
The holiday.
Holiday. What is the object actually being referenced?
It's a Christmas.
Christmas. So when we say they, when you compile, okay, when you compile, even if I comment this out, okay, you can see that it compiles, right? Because at compile time, it looks for that method in the reference type. That means at compile time, it looks at what reference type it is. It is a holiday. Okay, I'm going to go to holiday and see if you have that method. You have, that's fine. I'm going to compile. That's at compile time. At runtime though, it will go to the actual object, which is Christmas. Okay, if Christmas doesn't have it, it goes to holiday. But if Christmas have it, it uses the method in Christmas. That's called polymorphism, right? They celebrate. Okay, so right now at runtime, it will first go to Christmas because Christmas is the object being referenced. But Christmas doesn't have that method. I commented it out, so it will go to holiday. Okay. And it will say, let's celebrate this holiday, the very generic saying there, right? That's holiday. However, if you uncomment this one, right? Now it will go to Christmas. Let's lit up the Christmas tree. Okay, so that's what this means. Is that what this means? Yeah, this is what it means when we say this. And then this one, okay, I'm going to illustrate this one. Do you all understand this, everybody? Do you all understand this?
Yes.
Yes, okay.
Yeah, it's becoming more clear.
Okay, good. Okay, gradually, right? So now let's look at this. Why can we do this? Tell me why we can do this. It's about time, right? Why can we do this? Why? We can do this, but can you explain why? We are doing an assignment. Remember, always ask yourself, is this that? Is
Yes.
Thanksgiving holiday? Yes, then it's okay. Here is Christmas holiday. Yes, then it's okay.
Is
So
that shadowing?
no,
No?
this is not shadowing. This is polymorphism.
Okay.
Okay, so holiday, day is a holiday reference variable. At this time, it's pointing to a Christmas object. At this time, it points to a Thanksgiving object. That's polymorphism. If you go back, right, we said that at different times, a polymorphic reference, if you look at this, we are going to be a little bit out of time. A polymorphic reference is a variable that can refer to different types of object at different points of time, and that illustrates that. At this time, it's a Christmas object. Now it's a Thanksgiving object. So when you call celebrate, at compile time, it will go to holiday to look for that object, that method. At runtime, it will go to Thanksgiving. Okay, let's run. And you can see this is the second time we call it, right? It goes to Thanksgiving to call that method. This is, once again, polymorphism. Day is a holiday reference variable, but it changes at different times to point to different reference variable or different type of objects. Okay, can you be a little bit, can you stay a little bit longer? Let me do one more thing. That's what this is, get tree, right? Let's do that method. So public void get tree. Once again, I'm just using system.out.println to make it easier to implement. And okay. Get tree. Let's go and get a beautiful tree, right? Okay, so this is the get tree method. Does holiday have this method? No. Does Thanksgiving have this method? No. Okay, so here when we make it Christmas, and let's call this method dot get tree. That's what we were talking about here, right? We talked about this one here. So get tree, and you can see it doesn't compile. Why? So someone is asking, so you could add another along the lines of they, new. Yes, yes, definitely. If you define the Halloween class, you can say they, and Halloween has to extend holiday, which I forgot just now. Extend holiday, and then you can say they equals to new Halloween, definitely. Okay. So everybody, this doesn't compile. Why? Do you remember what I said? I said at compile time, where does it go and look for that method? Where? At compile time. It looks for the method in the reference type, right? In the reference type. So what is the reference type of day? Holiday. So at compile time, it goes to holiday to look for that get tree method, and holiday doesn't have it, so it doesn't compile. Does that make sense, everybody?
It does, but like, so if you run it, it won't let you compile it.
It won't translate it into object code. It will completely not compile. You cannot run it at all. Okay, so to make sure you are saying, okay, don't go and look for that method there, even though it's a reference, its reference type is holiday. I'm going to cast it, okay, specifically to Christmas. So go to Christmas to look for it. Oops. So this is casting day to be a Christmas object so that we can get tree. And that's why when I did the words, I'm telling you it's too complicated. Let's not do that for now, right? So here, when you cast it back into a Christmas object, you can, Christmas, now you are casting this reference variable at this moment temporarily into a Christmas reference variable. So it goes there to look for that method. That compiles. Does that make sense, everybody?
Yes.
Yes, okay. That is what this is. Get tree, it doesn't compile and you have to cast it back. And so, okay, how about this? Let's finish this one thing and then we will be done. If music player is the parent of CD player, are the following assignments valid? I have the answer there. So what you do is you ask yourself, is CD player, okay? Is CD player music player? You know, is a CD player a music player? If the answer is yes, then it's okay, right? But you do this, the reference type is CD player and the object type is music player. You ask yourself, is a music player a CD player? Not always. So you cannot say a music player is a CD player. Then it's not okay. Okay, that is that. So I think we are done today. We did do a lot of things.